All right, so I have three ionic compounds here: potassium carbonate, calcium chloride, and calcium carbonate. And looking at all three substances, we can see that they look somewhat similar, but also different. They're all white in color, but they're kind of different textures, I guess. The potassium carbonate looks like, I don't know, really small white spheres, maybe. We can see like individual grains of this salt really easily. The calcium chloride is made of larger chunks. And we can see if we look really closely that they kind of look a little bit chalky, maybe? I don't know. And then the calcium carbonate is a different texture from the potassium carbonate. The calcium carbonate looks like it is a finer powder. I can't really see individual grains. This one almost looks like flour, I guess, but it's still an ionic compound because it's made of calcium ions and carbonate ions. So those are my three substances. And what I'm going to do is I'm going to put some of each one in a different test tube, and then I'm just going to add some water, and we're going to see what happens. All right, so here is my potassium carbonate. Oh my, how am I going to do this? Here's my potassium carbonate. I'll just pour it in, I guess. That's good. I don't need all of it. And now I'll do my calcium chloride in my second test tube. That was maybe more than I wanted to. And then my calcium carbonate in my third test tube. And this one I really don't want a lot at all. I'll just do that tiny little amount right there. And now we'll just do water in each one. There's water in my potassium carbonate. Just swirling that around. And since it is an ionic compound, we know that it is likely to dissolve, but it may not. I'll add water into my calcium chloride now. About the same amount of water, and about the same amount of water into my calcium carbonate as well. Hello? I don't know why it's not working. This is awkward. I need to put this down, I'm sorry. There we go, okay. I don't know what was going on with my water bottle there. About the same amount of water in each one. And we can see now that my first one has settled, that it has dissolved completely. I don't see any more pieces of potassium carbonate. My calcium chloride is looking like it's starting to dissolve. And let's check on my calcium carbonate to see how that one's doing. Okay, so out of these three, remember that's potassium carbonate, calcium chloride, and calcium carbonate from left to right. It looks like the potassium carbonate dissolved the most. The calcium chloride seems to sort of be dissolving. We can see some bubbles. Do y'all see that? There's some bubbles there as it dissolves, I guess. I'm not really sure what that is. That is dissolving, right? I think that's definitely getting smaller. my calcium carbonate. I don't know that that's dissolving at all. Doesn't really look like it is. That's definitely getting smaller. Yeah, we can see it getting smaller. So that's interesting. The one on the left dissolved the easiest. The one in the middle is also dissolving, but it seems a little more reluctant. And the one on the right seems to not be dissolving at all, at least so far. Based on that, what do you think we can say about the strength with which these ions attract each other? My potassium and my carbonate seem like they are pulled apart from each other pretty easily by water. My calcium and my chloride ions seem to be a little bit better at holding on to each other because they're like resistant to dissolving. And my calcium and carbonate ions seem especially strongly attracted to each other. So that's interesting because my two ionic compounds containing calcium are like less soluble, I guess, than the potassium one. I think it probably does have something to do with the calcium because I don't think it's the carbonate because like, look, my carbonate is in my potassium carbonate and that dissolved really easily. So if we're thinking about like what causes something to dissolve well and what causes it to not dissolve well, it sort of seems like calcium might be like better at attracting its negative ion. You know, that seems to be true so far. We'd have to look at more, but yeah, that's kind of worth noting. Now what I'm gonna do is I'm going to take these two solutions. By the way, that's dissolved completely now. I'm going to take these two solutions of my potassium carbonate and my calcium chloride, and I'm going to combine them together in this fourth test tube here. Before we do that, let's just think a little bit more carefully about what's going to happen or what's going to be floating around in solution when I do that. Hold on, let me take a pen. Okay, sorry. Right now, floating around in my potassium carbonate test tube, I know that I have water molecules floating around, and I know that I also have potassium ions, little K pluses, and I also have carbonate ions, right, CO3s. And each of those has a -2 charge, of course. And I know that I have twice as many potassiums compared to carbonates. So I can put, I guess I should do 2 more. So now I have 1, 2, 3, 4 potassiums and 2 carbonate ions. That's representing what's in my test tube. And in this test tube, I have my calcium and my chloride. This time I have 2 pluses. And I'm going to have twice as many chlorides. So I'll do 1, 2, 3, 4 for my chloride ions. And in these two, notice how I drew the ions separated apart from each other. But if I look at my calcium carbonate test tube, it still hasn't dissolved, and it doesn't seem like it's going to at this point. So when I draw the contents of my calcium carbonate test tube, I'm going to draw them still together. So I have like a CaCO3 down here and another CaCO3 down there, and I have water, of course. I guess I should have put my water on this one as well. So I have water, water, water. In this one, my ions are broken apart, and in this one, my calciums and my carbonates are still together. And in this fourth test tube, I'm going to basically combine the contents of these two test tubes. So I will have floating around potassium ions and calcium ions and carbonate ions and chloride ions. So I'll have 2 different positive ions and 2 different negative ions, and they'll be floating around in water. So let's see what happens when I combine those 2 solutions in here. Well, actually, I don't even need to do that, do I? I can just pour one into the other, and that'll be my 4th test tube. So I'll pour this in here and we'll see what happens. All right, you ready? Here it comes. All right, and we'll swirl that around to mix it up. Whoa. What's happening? You guys see that? What is that? That, why won't you focus? That doesn't look like a clear solution, does it? It kind of looks like there's, look, you can definitely see solid on the side of the test tube there. It kind of looks like there's solid in there. Based on what I said was in my test tube, what could that solid stuff be? There's potassium ions in there, there's calcium ions, there's chloride ions, and there's carbonate ions. What did we say was true about calcium ions and carbonate ions? They're pretty good at attracting each other, aren't they? And look, when I mixed my 2 solutions, what did I do? I put calciums and carbonates in the same container next to each other. Do you think it is possible that they found each other? And if they found each other, even amongst all that water and all those other ions, could they bond to each other? I mean, it kind of seems like calcium and carbonate are so good at attracting each other that they can resist being dissolved. Apparently, even if they start out dissolved, if they get put in the same container, they can go ahead and become undissolved. They can undissolve themselves. That's pretty neat.